If you, your organization, or your customers are already leveraging the cloud, chances are that you already understand the need for infrastructure as code, or IaaC for short. Hi, my name is Tidjani Belmansour. I'm a cloud solution architect and a Microsoft Azure MVP. And in today's episode of Azure Back to School, we will take a look at Pulumi, which allows developers to do infrastructure as code in their favorite programming language. So let's get started. In order to use IaaC, or infrastructure as code, we first have to think in terms of cattle versus pets. You probably already heard this expression. Well, in a nutshell, cattle versus pets means simply that in the old days, we used to treat our servers as pets. We configure them, we make sure they have anything they need, and we take care of them. In the cloud world, we think of our servers more as cattle. So we use them, and once we don't need them anymore, well, we just kill them and recreate them as needed. Why? This because cloud environments or cloud resources in general are built per usage. Thus, cloud environment should only be up and running when we really need them or when they are in use. There are some exceptions though. Some resources can't be deleted and recreated as needed. For example, reserved instances. Many cloud providers promise of reduced cost in exchange of reserved instances. So you reserve some resources for 6 months, 1 year, 3 years, and you get a discount on these instances. So whether or not you use them, you still pay for them. So there is no need to delete and recreate those resources. Also, static IP addresses. Once you create, for example, web apps or web servers, and you want to assign static IP addresses to them, you don't want to delete these addresses because they will be freed up and someone else can use them. So you want to keep those resources for you. And obviously networking resources, for example, VPN gateways. So even if we delete some resources, we want probably our connections, for example, a VPN gateway between an on-premise infrastructure and the cloud infrastructure to still be there. Also, since we can now delete and recreate our resources on demand, doing manual creation provides the risk of an increased error or increased risk of error and configuration mismatch or drift. So each time we recreate those resources by hand or by clicking in some kind of portal or issuing some commands in a console by ourselves, we take the risk of forgetting a parameter or misspelling some name, etc., and thus having either error in our infrastructure or configuration drift between the previous deployment and the current deployment. And this is where IaaC comes to the rescue. So in an IaaC world, or infrastructure as code world, infrastructures as expressed as code. This code is executable, so it can be repeated, it can be executed as needed. So the bottom line is that each execution will lead to the same desired state. That's the premise of infrastructure as code. Code can be automatically triggered. For example, if we are in a DevOps context, we can deploy our infrastructure through an automated pipeline. And this code can also be versioned. So if the code is versioned, that means the infrastructure can evolve over time to match the application code needs. So in IaaC world, there are obviously multiple technologies. If you are on Azure, you probably already heard of ARM templates. or the newly domain-specific language which is called Bicep. If you are an AWS fan, you probably already heard of CloudFormation. And if you are in a multi-cloud context, so you probably already heard of Terraform, Ansible, and Pulumi, and there are plenty of other technologies. Yeah. So it's important to remember that all of these technologies aim for the same goal, which is expressing our infrastructure as code and being able to deploy it in a repeatable manner, automated manner, in reducing the risk for errors and configuration drift. Most of these technologies are idempotent. What does it mean? It means that if we run or issue the same command multiple times, it will lead to the same result. Why I'm mentioning this? Because there are some technologies. For example, if I create a resource using a PowerShell, an Azure PowerShell command, chances are that the first time the command will complete successfully, but the second time I will get an execution error because the resource is already there. So I have to code, to structure my code in a defensive way. What does it mean? It means that I simply have to check for the existence of this resource prior to creating it. It's worth mentioning that each technology has its own particularities. Some are declarative, that means we express what we want to get as a result, or what is the infrastructure we want to get, and let the technology or the framework or the library do the job in order to get or reach for that result. Some of them are imperative. That means that we have to give or detail step by step what to do exactly in order to get that result or that desired state. Also, some of them use programming languages, such as Pulumi, for example, and the target audience for this technology are obviously developers. And some others use scripting languages, for example, PowerShell or Bash, etc. And those technologies aim for IT pros as an audience. Some of technologies are vendor specific. For example, Bicep, ARM templates, and CloudFormation are vendor specific. And some are multi-cloud. For example, Terraform and Pulumi are multi-cloud. What does it mean? It means that we can use those technologies in order to script infrastructure targeting multiple clouds. And finally, some of these technologies use a state file in order to determine what needs to be done to reach that desired state, while others refer to the real infrastructure, the deployed infrastructure or the existing infrastructure on the cloud provider in order to determine what needs to be done in order to get to that in a desired state. What needs to be done means either creating some resources, updating resources, or deleting existing ones that are not needed anymore. So what is Pulumi? Well, Pulumi is a declarative technology. That means we express as code the desired state that we want to reach, and we will let Pulumi identify the steps required to reach that state. What does it mean? It means that Pulumi will determine or identify if it needs to create resources, delete resources, or update existing resources. Pulumi also rely on programming languages, means .NET, Python, Go, JavaScript, which obviously target developers and not IT pros, which may be less familiar with programming languages. Pulumi can express an infrastructure that can be deployed on multiple cloud, whether Azure, AWS, GCP, or Kubernetes. And Pulumi uses a state file in order to, or a state backend, we'll get back to this later, in order to identify what needs to be done to reach out to that state. So, about the tools. Well, the required tool, the minimum tools we need in order to use Pulumi are a code editor. For my case, I used Visual Studio Code, which can be installed using Chocolatey if you are on Windows, such as I do. Or if you are on macOS or Linux, there are also commands for that. Brew command line for macOS and apt-get for Linux. And then install Pulumi. So since I'm on Windows, I can use Chocolatey CLI to issue command to install Pulumi and upgrade my installation of Pulumi. So now that we have our tool installed and our dev box configured, let's take a look at how we create a new project in Pulumi. So I'm now on my dev machine, and you can see here I have a Visual Studio Code already installed. So first of all, I will start my Visual Studio Code. I will open a terminal and go to my desktop. Okay. I will first create a folder. Let's call it Azure Back to School Pulumi. And open that folder. Okay. Now, what I can do is using the Pulumi CLI to create a new project. In order to do that, I type Pulumi new and hit enter. As you can see, we have multiple project templates. Some are prefixed by AWS. That means they target the AWS cloud, and we can either use C#, Go, JavaScript, TypeScript, or Python in order to express an infrastructure that will be deployed on AWS. We have the same thing for Azure. You can see here Azure-C#, Azure-Go, Azure-JavaScript. You get the idea, which means that we can define an infrastructure in either of these programming language that will target the Azure cloud platform. Same for GCP, and we have the same for Kubernetes, right? So we also see here that we have show additional template. So if we show additional template, you see that we have more targets for our infrastructure. Okay. So, as you may guess, this is not the easiest way to create a new project. So let me show you another way. It still relies on the Pulumi new. And since I already know that I will be targeting Azure, I can use the Azure template. And I will be using C#. And I can use the -y to say yes. So as you may see here, the project is being created. Its dependencies are being installed, and it's a .NET build command that is being used to restore the dependencies. Okay, so now our project is created. Dependencies are being downloaded, and you can see here our project is now ready to go. So we have everything we need for our project. So now let's take a look at the project structure. So back in our dev machine, we'll open the folder that we created. And we can see that Pulumi created some files for us. Okay, so the first one is the CS proj. What we can see here is that we have a reference, a package reference to a NuGet package called Pulumi.Azure native. The second file worth mentioning is the Pulumi.yaml file. This file actually hosts metadata about the project. As you can see here, that's the project name, that's the runtime, it's .NET, since we are using C#, and a description. Okay, free text, so you can type it anything we want. Let's say we want to say introducing Pulumi for Azure Back to School event. We can also see that we have a program.cs files, which is our entry point. So you can see here the main method, which does only one thing. It actually starts deployment of the class MyStack. This class is here. So here we have reference to the Pulumi.Azure native library, and we have the MyClassStack, which is a class that inherits from the stack class. Okay. And we already have an example that deploys an Azure resource group and an Azure storage account inside of that resource group. So what we'll be doing here is that we will deploy a demo application. Let's take an example. We'll be deploying an Azure resource group. Inside of that resource group, we'll be deploying an Azure App Service Plan, and this App Service Plan will host an Azure App Service web app. So back in our dev machine, we'll get rid of all of that. Okay. So let's rename the MyStack class to ABTS for Azure Back to School Web Application. And also rename the class constructor. And in order for that to work, I'm going back to my program.cs and ask it to deploy the ABTS web application stack. Okay. Let's add stack at the end of the name here. Stack. Okay. So now the first thing that we will be creating an Azure resource group. Then we'll be creating an Azure App Service Plan and creating an Azure Web App. Or to be correct, it's not creating, it's expressing the desired state of an Azure resource group. Here expressing the desired state of an Azure App Service Plan, and here it's expressing the desired state of an Azure Web App. Okay. So how do we do that? Well, in Pulumi, there are classes that represent Azure resources. So for example, here we'll get our resource group and we'll have an Azure resource group, or not Azure, it's just resource group. And most resources in Pulumi use two parameters at least. The first one is just a name. It's an identifier for the Pulumi code. Okay, so let's say abts rg for resource group. The second one is the resource group's arguments. What is this? It's an object in which we'll define the desired state actually. So for example, for the resource group, we want a location. Okay. Let's say Canada Central. We'll also want a resource group name. Let's say abts -rg. Okay. Let's say we also want to add some tags to that resource group. We can do that. Let's say our tags key will be project, and the value will be abts 2021 . Okay, so now we have our resource group. Then we will create our app service plan. Let's say plan and say app service plan. Okay, we need our using, and same here. We will need a name. Let's say app plan and an argument class app service plan args in order to express the desired state of that app service plan. So we've got the new here. Okay, so what we want first is a name for our app service plan. Okay. Let's call it abts plan. We'll also want a location. Okay. So here we have two options. We can still say Canada Central, like this, or we can get the location of the resource group. How do we get that? By using the RG object and access its location property, just like that. Then we want the resource group name. Same here. We get that from the resource group. We specify the kind. Here it's app. Why is app? It's because we are creating a Windows app service plan. And then we will need a SKU for the app service plan. And the SKU for the app service plan is actually an object. So it's a SKU, not sky, SKU description args. And this one comes from that input. Okay. We specify the name of that SKU, which is B1, and the tier, which is basic. And here we have expressed the desired state of our Azure App Service Plan. Now to the web app. So, same here. You get the idea here. We'll create a web app. A new web app. We specify the name, abts web app, and the args. So web app args. So we need the name. We'd say abts web. We need location. We can get this location either from the resource group or from the app service plan. Let's get it from the app service plan here. Say plan.location. We'll get the resource group name from the resource group. We need a server farm ID, which is the plan.id. And here, look at that. It's an output of string. Okay, I'll get back to this later. Essentially, what does mean? That this ID is not known at this moment. Okay, why? Because it will be known once the plan or the app service plan is created. Once it will be done, the app service plan will be created. This ID will be known and it will be passed here as the value of the server farm ID property. Let's say we want only HTTPS, which a good practice, remember it. And let's add some app settings just to show you how to do that. Okay, so it's in the site config section. We'll create a new site config args, and here we can either create app settings, we can create connection string, we can create a command line argument, etc. We'll say app settings. And here, let's create a new name value per hour. The name will be, for example, ASP.NET Core underscore environment. And the value will be, in this case, dev. All right. Now we have our app service. So now we are ready to do our first deployment. So let's open a new terminal. And in this terminal, we'll first log in to Pulumi. So let's say Pulumi login. And as you can see here, I'm already logged into Pulumi using my GitHub account. And you can see here my Pulumi portal. My Pulumi dashboard here, my project, and you can see here we already have the ABTS Pulumi we just created with a dev stack actually and currently. Okay, so what is that portal and why do we need it? First of all, if we were not logged into that portal, let's say we go to Pulumi.com, or we need to sign in. You can see here we are redirected to the app.pulumi.com, and we can sign in with one of these identity. Okay, GitHub, GitLab, Atlassian, email, or via SSO. For my use case, since I'm not in an enterprise, I'm just personal account, I used my GitHub account. Okay, so now I'm logged into Pulumi with my GitHub account. So why do we need this? Well, our Pulumi dashboard stores information about all our projects, our stacks, and the deployment in those stacks. Okay, so if we click on the dev stack here, we can see that right now we have no resource and no deployment. Okay, there's no updates in Pulumi's terminology. There is no update already done. So we'll get back to this portal once we do our first deployment. So in order to do our first deployment, we also have to log into our cloud provider. So in my case, I will be deploying my resources on Azure. So I will do the Azure login, okay, and log into my Azure account. Since I'm already logged in, so I can make sure of that by on AZ account show, and you can see here I'm already logged in, and I'm making sure that I'm logged into the right subscription. So now what we can do is a Pulumi up for update. So the first step, it will be previewing our update. So it will be comparing the last known state on the Pulumi portal here with the desired state that we expressed here as code. Since it is our first deployment, so there is no previous deployment, no state stored on the Pulumi portal. As you can see, all the resources are marked for creation. So all those resources will be created. And here I'm asked whether I want or not to do the deployment. So in this case, we'll say yes. And here the update is actually done. So the deployment is actually in progress here. So we can see here the resource group is created, the app service plan is creating, now it's created, and then the web app is under creation. Great. So now we have our resource created. We can either go back to the portal. Okay, let's go back to the portal here and refresh it. And here we see we have already one deployment. And we have the same information. Let's take a look at the timeline here. Configuration and the environment. We can also look here at the resources that were deployed, and I simply have to click here on the Azure logo in order to be redirected to my Azure portal and access those resources. And it works. So our web app infrastructure is here and is ready to receive the code that I want to deploy. Okay. If you remember from our code here, we have added an app settings, ASP.NET Core, oh, I misspelled it, ASP.NET Core environment, dev, and if I go here, ASP.NET Code environment, dev, right? And if I go back to the resource, up here, to the resource group, here we have added a tag, project ABTS 2021, and we can see that this tag is here. We have done our deployment in the expected location, Canada Central. So our first deployment is a success. One thing to note here, you may be asking yourself, how did Pulumi determine the order of the creation of the resources? Well, a hint for you is that it's not because we defined those objects in that order. Yes, in this case, because it's the same order, but it's not the criteria that Pulumi relies on. Actually, Pulumi relies on references. So look at this. Here, the RG, or resource group object, has no references or any other resources. So it can be created independently from any other resource. We see here also that the app service plan has a dependency on the resource group. So the app service plan can't be created unless the resource group is already created. And the web app, here it has two dependencies on the app service plan and the resource group here. So the web app can't be created unless resource group and the app service plan are both created. Okay, that's why the state here, the stages actually, was reflecting these dependencies. And this is the criteria that Pulumi uses to build its dependency tree in order to create the resources in the right order. So now we have our first deployment. It's done. So let's have a word about state management. So if we take a closer look at how the deployment actually happened in Pulumi. So this diagram comes from the Pulumi documentation right here. Okay. So we issued a Pulumi up command through the CLI. The CLI triggered the engine, the Pulumi engine, which asked the language host. You see here it's a JavaScript code, but in our case it's C# or a C# library. So the engine called the C# library, and the language host went through that C# code, okay? And for each resource that it found, it actually issued a resource registration to the engine. Okay, so hey, here is a resource group. Okay, hey, here is an app service plan. Here is a web app. Okay, so the engine now knows about the resource to create, update, or delete. In our case, it was only creation. Okay, so now the engine goes to the state file. Okay, so it's our portal that acts as a state service which hosts the state file and compares what the resources, the expected state is expressed in this code and what is the last known state on the cloud platform. It compares those and determines what needs to be created, updated, or deleted. Once it has done that, it will issue commands to the cloud providers. In our case, it's Azure, and it will write the state to the backend state. So in our case, it's the Pulumi service. I won't go into the details for this session, but there are ways to use something else as a state service. We can use, for example, an Azure blob storage, an S3 bucket, or we can also host the Pulumi portal in our own infrastructure. If we want the Pulumi portal not to be exposed over the internet, we want to have one specific or our organization, which is private, we can host that portal inside of our data center. It's actually based on containers, and there is, in the Pulumi documentation, there is an explanation on how to do this. Okay, so we won't be covering that for today. And this is how the state management works. So next time we will issue another deployment, it will pull the last known state and compare the new script with the last known state. Okay, so it's updating that state after each deployment. Now let's talk about configuration variable now. Going back to our DevBox, we can see here that we have the location, the resource group name, the app service plan name, and the web app name here, hard-coded. Okay, it's not a great idea to do that. Every developer knows this. So we want to rely on variables. Okay, so how can we use or create configuration variables and pass them to our Pulumi code? So we mentioned earlier that we have a dev file here. Okay, so the pulumi.dev.yaml, and I didn't talk about it earlier for a reason. It's because I will be talking about it right now. This file actually is used to store configuration variables. So here, let's say we want to define the variables for our location. So Canada Central. For the app plan name, for example, which let's say it will be ABTS plan. The RG name, the source group name, which is ABTS RG. Okay. And here we'll go back to my stack and remove all of this. So how can we access the variable in this file here inside of our class? So luckily we can access the configuration in Pulumi through an object. Let's call it config. Config, like it's a config variable. Okay, so here what we can say is config dot, as you can see, we can either have get or require. We'll use require and I will tell you why. Okay, so here we say location, right? Okay, require means that if the value of the parameter is not found in the configuration file, there will be an exception and the code will stop executing. If we use get, that means if the value is not found in the configuration file, the null value will be returned. Okay, so require is for mandatory parameters, the get is for optional parameters. Since location for me is a mandatory parameter, I will get it as a required. Same here for the app plan name. Okay, app plan name, and same also for the web app name. And here for the RG name. Okay. So I guess I didn't add this. Okay, I didn't add this parameter. Okay. We'll say ABTS web. Okay, let's make sure ABTS web. Okay, right, great. Now, if I issue a new deployment, remember how we do this? Pulumi up. Yes, you're right. Up for update. Oh. Apparently I forgot something. Okay. What did I forget here? Actually, the message tells me something. It's I need to specify a namespace here. As you can see here, the configuration here, the first parameter uses the Azure-native colon location. So the parameter name is location. Azure-native is the namespace. Here I will use the Azure namespace. Since those parameters are for Azure resources, I will use the Azure namespace. Now, in my instantiation of the config object, I need to pass the namespace. Let's do this again. Pulumi up. And now you can see everything works fine. We issued a new deployment. And if everything works well, we should have no updates, since we didn't change our infrastructure, we just replaced variable. And here it is, for and change. So there is nothing we did to our infrastructure. And here, notice it asks me whether I want to do this update or no. Why is Pulumi asking me this? Since there is actually no changes. Well, if I say yes, it will log this trial actually in the state file. So it will store that we asked for a deployment and that there was nothing to be done actually. Okay, so in this case, I don't want to pollute our my state file. I will simply say no. Okay, so now I can rely on configuration. Why are we talking about configuration? Well, because here we want to have another instance. For example, we deployed the dev instance, we want to deploy the prod instance, okay, production instance. How do we do that? Let's get back to our code. Okay, here we need to create a new stack. Here we have a pulumi.dev.yaml. So if I do a pulumi stack ls, we can see that we have a dev stack which was deployed the last deployment happened 16 minutes ago. And here now I want to create a new stack, so it's pulumi stack init, let's call it prod. And now if I list my stacks, we can see that we have a dev stack and a new stack called prod. The star here means that it's the active stack. Keep in mind that when you issue a deployment using Pulumi up, that deployment happens in the active stack. Okay, so now I will create a new pulumi.prod.yaml file. And in this file, I'll copy this and here I will say web app prod. Let's say here that it's prod. Okay. Let's keep it that way. So now if I issue a new deployment, as you can see here, it will create those resources. Why? Because it's in a new stack. It's a prod stack, so there it wasn't deployed earlier. So yes, I want to create that. Okay, deployment happened. If if I go back to my Azure infrastructure, here in my resource groups, and I filter by ABTS. Okay, I have the ABTS prod here, along with the ABTS RG. I have the ABTS service plan here, and the ABTS web prod. Okay. And now I can see the ABTS prod Azure website. Let's talk about the outputs. Okay, what are the outputs actually? So let's say I want to return the hostname after the deployment actually happened. Okay, so here, back in my code, I will create a property, public property actually, which is an output of string, and I will call it the web hostname or web app hostname. Okay, so this is a getSet property, and it's decorated with the output attribute. Okay, now the deployment happened. Okay, here set the output value. How do we do that? Web app hostname here, web app, and I get the default hostname on that web app, and I use the apply method. So once I get the value of the default hostname, this happens after the web app is created. So we get its hostname into the default hostname variable. And what I will do here, I will take that value and say https :/ plus host. Okay, so once that default hostname value is available after the web app is created, I will take that value and store into my output variable here https :/ with the hostname that was provided here. Okay, so if I do that and I issue another deployment now, okay, so now what we'll have as a result is an output variable that will contain the value here. Okay, so now we'll click yes and let the update begin. So there is, as you can see here, there is no change happening to the resources. The only additional thing here is that we will have our hostname. Let's go back to our Azure portal. You can see here we have two resource groups, the ABTS prod RG and the ABTS RG, which hosts the dev version of our website. As at the beginning of this session, we said that in a cloud environment, we don't want to keep resources up and running 24/7, 365 days a year. Okay, some of them are intended to be available all the time, like the prod environment, obviously. Some of them not. Think of, for example, of an environment that its sole purpose is to do performance and load testing. So you will spin up this environment, do your test, and delete that environment after your tests are completed. You don't want to keep that environment up and running 24/7, 365 days a year. Okay. So let's say we want to delete these environments, the dev environment. So remember that all deployments happens on the active stack. So you remember how we list the stacks? Pulumi stack ls. So we have our stack here, and we have the prod stack, which is the active one. We want to switch to the dev stack. Okay? How we do that? We say Pulumi stack select dev. Okay, and now if we list our stacks, we still have two stacks, but the dev stack is the active one now. Okay, so now we want to delete that deployment. Okay, so say Pulumi destroy and we'll be destroying the deployment on our dev stack. So I can see here the dev stack, and it will delete all the resource. Let's confirm the deletion of our dev stack. Okay, now the resources have been deleted. Let's take a look at our stacks again. So here we have no more resource on the dev stack, but we still have resources on the prod stack. So going back here, as you can see here, there is no resource now in the dev stack, but in the prod stack we still have resources. If we click on the browse button, we can see that the prod version is still up and running. And this concludes today's episode. This is our overview of Pulumi. I hope that now you have a clear view of what is Pulumi and how to use it. Tell me what you think in the comment section below, and if you enjoyed this video, please give it a thumbs up. This is Tidjani Belmansour. Thank you for watching, and see you soon. Bye bye.